Okay, imagine this. Those mysterious cosmic monsters everyone's always talking about. Black holes, they might not even exist. Crazy, right? We've grown up hearing how they're these terrifying vacuums sucking up stars, planets, and even light itself. But what if they're not real at all? What if black holes are just a big misunderstanding, a placeholder for things we haven't quite figured out yet? Today, we're diving deep into the mystery and asking some tough questions about whether black holes are fact or just a convenient fiction. Buckle up for this cosmic roller coaster. Alright, let's break it down. Black holes, according to the textbooks, are these insanely dense regions of space-time where gravity is so strong that absolutely nothing, not even light, can escape. Think of them as gravity on steroids. The idea is that they form when massive stars collapse in on themselves, creating something so dense that it warps space-time itself. At the heart of a black hole is what scientists call a singularity, where all the matter is squished into an infinitely small point. Around that is the event horizon, the point of no return. Sounds intense, right? And here's the kicker. They come in different sizes. So, we have the stellar black holes. These are like the small fry of the black hole world. They form when massive stars run out of fuel and collapse. They're usually a few times the mass of the sun, but they pack a serious punch in the gravity department. After that, there are the supermassive black holes. These are the big bosses. They hang out at the centers of galaxies and can be millions or even billions of times more massive than the sun. Scientists think they might have something to do with how galaxies form and grow, but honestly, we don't really know how these beasts came to be. Then, last but not least, the primordial black holes. Now, these are more of a what-if scenario. The theory is that they could have formed right after the Big Bang, from tiny ripples in the density of the early universe. If they exist, they might even explain some of the mysteries of dark matter. Black holes are credited with shaping galaxies, creating gravitational waves, and powering some of the most energetic phenomena in the universe, like quasars. But here's the thing. How much of this is actually backed by solid evidence? Could we just be seeing what we want to see? Now, let's get into the juicy stuff. Why black holes might not actually be what we think they are. There are some pretty big problems with the theory, and they're not just nitpicks, they're fundamental issues. Alright, so at the heart of every black hole, there's supposed to be a singularity, a point where gravity crushes everything down to infinite density. Infinite. Let that sink in. Science doesn't usually like infinities. They're a big red flag that says, something's wrong here. How can the laws of physics just break down? Shouldn't nature have a better solution? You've probably heard of Stephen Hawking, right? He proposed that black holes aren't totally black, that they slowly lose mass over time by emitting something called Hawking radiation. Sounds cool, but here's the catch. It's never been observed. It's all based on theoretical math. And while the math is fascinating, it doesn't mean it's true. Until we can actually see this radiation, it's just a hypothesis. The event horizon is what makes a black hole, well, a black hole. It's the point where not even light can escape. But here's the thing. We've never actually seen an event horizon. Even that famous image from the Event Horizon Telescope, the one with the glowing ring around a shadow, that's not direct proof of an event horizon. It's an interpretation of data, not a smoking gun. So, if black holes aren't what we think they are, what could they be instead? Let's talk about some of the alternative ideas out there. Some of these are pretty wild, but hey, science is all about thinking outside the box. Imagine a black hole without the scary singularity. That's basically what a gravastar is. Instead of collapsing into an infinitely dense point, a star could form a shell of exotic matter surrounding a vacuum. It would look and act a lot like a black hole, but without breaking the laws of physics. Cool, right? What if what we're calling black holes are actually just dense clumps of dark matter? Dark matter is this mysterious stuff that doesn't emit or absorb light, so it's basically invisible to us. If it clumps together in dense regions, it could create gravitational effects similar to black holes. String theory, anyone? Fuzzballs are an idea from string theory that replaces singularities with tangled up strings. Instead of a single point of infinite density, you get a compact object made of these strings. It's all theoretical for now, but it's a fascinating alternative. This one's a mind bender. Einstein's theory of general relativity says that light bends around massive objects. So, what if the shadows we're seeing are just tricks of warped light? Maybe black holes are just cosmic mirages created by space-time bending in weird ways. Alright, here's the wild card. What if we're living in a simulation? If that's true, then black holes could just be programmed constructs, cosmic Easter eggs designed to follow certain mathematical rules. Think about it. They're just mysterious enough to keep us intrigued but impossible to fully understand. Convenient, huh? Now let's talk about the so-called evidence for black holes. Spoiler alert, it's not as airtight as you might think. Remember that famous image from the Event Horizon Telescope? It showed a shadow surrounded by a bright ring, and everyone said, "Look, it's a black hole." But critics argue that this shadow could also be explained by things like gravastars or dense clumps of dark matter. The image relies on indirect data and heavy computer modeling, so there's a lot of room for interpretation. Gravitational waves are ripples in space-time, and their discovery was a huge deal. Scientists say they come from black holes merging. But here's the thing. Couldn't these waves also come from other massive events, like neutron star collisions, or even exotic objects we haven't discovered yet? Some black holes shoot out massive jets of energy, like quasars, which are some of the brightest objects in the universe. But wait a second. If nothing can escape a black hole, how are these jets getting out? Doesn't that seem like a bit of a paradox? Maybe these jets are evidence of something else entirely. Alright, let's get conspiratorial for a second. If black holes might not exist, why does the scientific community cling to them so tightly? Here are a few possibilities. Let's be real, black holes are cool. They capture the public's imagination and bring in billions of dollars in research funding. Scientists and institutions benefit from this attention, so there's definitely an incentive to keep the black hole narrative alive. Admitting that black holes might not exist would be a huge blow to physics and cosmology. It would mean rewriting a lot of what we think we know. How many careers and theories depend on black holes being real? Probably a lot. What if black holes are a smokescreen, keeping us focused on one mystery while bigger truths about the universe go unnoticed? Maybe it's a way to divert attention from deeper questions about dark matter, quantum gravity, or even the nature of reality itself. So, there you have it, the case for and against black holes. Are they the cosmic titans we've been told about, or are they just illusions built on shaky science? Could they be gravastars, dark matter clumps, or even glitches in the matrix? Question everything. Answer a question with another question. After all, isn't all science about that? Let's keep the conversation going. Share your thoughts, and as always, stay curious and keep looking up.